We all know about services, microservices, and APIs. They're literally everywhere. We know why we want to build them. Amongst other things, we get clear ownership, encapsulation, speed with which we can make changes due to the explicit interfaces. That's about how we encapsulate business logic. But what about the data that these services are managing? Here is a typical flow of data for a service, beyond the primary storage. What happens, right? You have your primary database, let's say here MySQL. It then is streamed typically through change capture, Debezium, lots of us will be familiar with it, into a landing zone like data in the data lake, which is where transformations happen to sort of make a modeled data set out of it, right? And then that data set is consumed for reports, business dashboards, and so on. So a quick, toy example, here's your user table in your MySQL, lands as is in your landing zone, bronze data, then gets transformed looking at that is registered flag to generate a daily registered users data set. But what you notice is that service teams are thinking about their MySQL and not really thinking about what happens to the data after it goes into this offline world, right? Because this is a couple of degrees away from them. Somebody else is potentially transforming this. The problem here is that now, because your raw data is getting shipped off, your implementation details are leaking. Let's say, instead of a Boolean is registered flag, the service team decides to track more granular states here, right? And says, okay, we'll create a separate user registration table that's going to sort of track those steps. They do that, but what happens to this daily registered users report? It's going to break because it was depending on this internal flag. This team wouldn't possibly even know that that's going to break. They would know it maybe sometime later. You'd need coordination between, okay, why did this report break, to triage down to, oh, the source data changed, right? So the user team didn't even know that their specific implementation choices are now relied a couple of degrees away. All kinds of choices, right? Data layouts, stores, data types. In this world, how can that service team actually fulfill that initial promise of making quick changes independently and evolve their implementation? Because now they have this, when they want to change their data layout, they have these dependencies all around and need to coordinate with these consumers. We know how to solve this in the business logic and the API world. We know how to make API abstractions, how to version them, and how to evolve them. So let's actually just start doing the same for data. What does that mean? Think of your services as essentially having two types of interfaces. One is your typical RPC or REST APIs. And the second set of interfaces are essentially your data contracts or data interfaces, right? Database becomes your private implementation, truly private, data on the inside, and use events as a way to fulfill those data contracts for this data on the outside. That makes it very explicit. The schema makes it very explicit so that your consumers now know what to depend on and can evolve accordingly, right? So going one level deeper, what does the implementation look like? Like I said, put your event schemas alongside your service repos so that they're right there, both of your interfaces. You can potentially sync them to something central, like an Artifactory repo, schema registry, even Git submodules. All that's fine. typically use one event topic per domain object, and fact carrying dense events to expose your data. And we can borrow some of the ideas from change capture about how you can put the current state of the entity, the previous state of the entity, what's changed, so that the consumers of your data are sort of self-sufficient, don't need to do a callback into your service to actually get that data. Additionally, because now you think of your services as having two interfaces, you can try to keep those APIs and these event schemas aligned so that while implementing your data transfer objects or your beans and all of that can be shared between these interfaces where possible and reduce the boilerplate. Move away from Debezium and raw change capture as a way to expose your data beyond your domain. And then the things that we know from API world, versioning your schemas, having a clear process on when there are breaking changes, how you want to make those breaking changes, having forward compatibility so that you can add stuff to your events, and so on, right? So why do all of this? What do we get from this? Like we said, now with your explicit data on the outside contract, you can change your internal implementation however you want, most likely driven by new functionality, oftentimes performance. You can have a different layout. Let's say you have a fully normalized layout of your data internally, but the way you want your consumers outside of your service or domain to consume it may be more denormalized form. Your consumers don't have to deal with your pesky, badly named column and try to infer what those mean, all sorts of things, right? Now, there's a true decoupling between your internal implementation and what consumers are consuming. But even more importantly, now you can define and control what data from your domain actually gets exposed outside. You don't need to spill all the guts of your join tables or of your schemas and so on to outside your domain, right? There is only a limited surface area that you potentially want to expose. This will allow you to now start doing that, right? It sets clear expectations, change management, all the things that we've learned from APIs. Trivial changes to your tables like we just saw don't blow up into breaking something further downstream, leading to cross-coordination projects. And as you start doing this, you start building reusable building blocks or reusable schemas, and almost like a data vocabulary for your systems that you can start to have a comprehensive view of the data. I'll quickly flash this. As you start doing this, things to think about, transactionality, data backfills, how do I fix mistakes so far in the data, backfills, like I said, all of those things you'll have to think about along this line. Each of these has several solutions that you can sort of go through, but something to think about. So that's it. Last but not the least, I want to leave you with this. Start adding your event-based data contracts to your design docs, just like you add your APIs, so that now you're very purposefully thinking about data on the outside. Thank you. That's my talk.